You can run one 1-inch conduit from the motor control center to a junction box at the 3 motors with all of the power and control wires in it, then out of the junction box to each motor and control station. The current National Electrical Code, or NEC, does not have a rule prohibiting the combination of load and control wiring for multiple motors within a single conduit. The 2008 NEC allows multiple conductors to be installed in a single raceway, provided that the raceway offers sufficient capacity to accommodate the conductors and that all conductors are correctly identified. Several factors need consideration when combining motor power and control wires in the same conduit. Firstly, consider conductor ampacity. The ampacity of conductors must be determined per NEC section 310.15. Ensure that the conductors you select can handle the anticipated load. If multiple current-carrying conductors are installed in a single conduit, ampacity adjustment factors as outlined in NEC Table 310.15 or 310.15b3 must be applied. Secondly, think about conductor identification. NEC Section 310.11 requires that all conductors be clearly identified as to their purpose. Control wires should be uniquely identified to differentiate them from power conductors. Color coding, tagging, or labeling are acceptable methods for conductor identification. Thirdly, consider the conduit fill. The number of conductors allowed in a conduit is limited by NEC Chapter 9, Table 1. The conduit must have enough space to accommodate all conductors and any necessary bonding jumpers. Overfilling a conduit can lead to overheating and insulation damage. Fourthly, regarding control circuit classification, NEC Article 725 classifies control circuits based on voltage and power levels. Class 1, Class 2, and Class 3 circuits have different requirements for wiring methods and overcurrent protection. Verify that the control circuits in the system comply with the correct NEC classification. Fifthly, consider the grounding and bonding requirements. NEC Article 250 outlines the requirements for grounding and bonding electrical systems. The metal conduit must be properly grounded to provide a low impedance path for fault currents. Grounding and bonding conductors must be sized according to NEC Table 250.122. Sixthly, regarding overcurrent protection, each motor must have its own overcurrent protection device, as required by NEC Article 430. The overcurrent protection device protects the motor and conductors from overload and short-circuit conditions. Verify that the overcurrent protection devices are correctly sized for the motors being served. Seventhly, consider the motor disconnecting means. Each motor must have a disconnecting means located within sight of the motor, as required by NEC Section 430.102. The disconnecting means allows the motor to be energized for maintenance and repair. The disconnecting means must be rated for the voltage and current of the motor circuit. Eighthly, regarding the junction box must be sized per NEC Section 314.16 to provide enough space for the conductors and any splices or terminations. The junction box must be accessible after installation. The junction box must be suitable for the environment in which it is installed. Ninthly, when dealing with motor control centers, or MCCs, NEC Article 430, Part 8 provides specific requirements for motor control centers. MCC must be listed and labeled per UL 845. MCC must be installed per the manufacturer's instructions. Tenthly, regarding the ambient temperature correction, NEC Table 310.15b2 provides correction factors for conductor ampacity based on ambient temperature. If the ambient temperature exceeds 30 degrees Celsius, the conductor ampacity must be corrected. 11thly, consider the voltage drop. Voltage drop can affect the performance of motors and other electrical equipment. NEC Section 210.19 AM provides guidelines for voltage drop in branch circuits. It is recommended that the voltage drop in the motor circuit not exceed 3%. 12thly, regarding the conductor types, NEC Table 310.104 lists the allowable conductor types for various applications. Conductors must be suitable for the voltage, temperature, and environment in which they are installed. 13thly, consider the short circuit current rating. The electrical system must have an adequate short circuit current rating to withstand the available fault current. The short circuit current rating of the equipment must be equal to or greater than the available fault current. 14thly, it's important to consult with local amendments. Local jurisdictions may have amendments to the NEC that must be followed. Always check with the local electrical inspector to determine if any local amendments apply. 15thly, regarding professional installation, it's always best to have electrical work performed by a qualified and licensed electrician. A qualified electrician will have the knowledge and experience to install the electrical system safely and per the NEC. 16thly, consider the wire size for the control wires. Although the NEC does not specify minimum wire size for control wires in all cases, it is generally recommended to use at least 14 American wire gauge or for control circuits. This size provides sufficient mechanical strength and current carrying capacity for most control applications. For longer control runs, a larger wire size may be needed to minimize voltage drop. 17thly, regarding separation of power and control conductors in the junction box, while not strictly required by the NEC, it is good practice to maintain some physical separation between power and control conductors within the junction box. This separation can help prevent accidental contact between the conductors and reduce the risk of electrical noise interference in the control circuits. 18thly, consider the use of barriers or dividers. Barriers or dividers can be installed inside the junction box to provide physical separation between power and control conductors. These barriers can be made of plastic or metal and should be securely fastened to the junction box. 19thly, when dealing with terminal blocks, using terminal blocks can help organize and manage the control wires within the junction box. Terminal blocks provide a convenient way to connect and disconnect control wires. Terminal blocks should be rated for the voltage and current of the control circuits. 20thly, regarding wire markers, using wire markers to identify each control wire is essential. Wire markers should be placed on both ends of each control wire. Wire markers should be durable and easy to read. 21stly, consider the documentation. Maintaining accurate documentation of the electrical system is important for future maintenance and troubleshooting. Documentation should include wiring diagrams, panel schedules, and equipment specifications. Documentation should be stored in a safe and accessible location. 22ndly, regarding periodic inspections, regular inspections of the electrical system can help identify potential problems before they become serious. Inspections should be performed by a qualified electrician. Inspection should include a visual examination of the wiring, connections, and equipment. 23rdly, regarding training, providing training to personnel who operate and maintain the electrical system is important for ensuring safety and reliability. Training should cover the proper operation of the equipment, the identification of potential hazards, and the procedures for responding to emergencies. 24thly, think about surge protection. Surge protection devices can help protect sensitive electronic equipment from damage caused by voltage surges. Surge protection devices should be installed at the main electrical panel and at any equipment that is particularly susceptible to surge damage. 25thly, regarding harmonics. Harmonics are distortions in the electrical waveform that can cause problems with equipment operation and energy efficiency. Harmonic filters can be used to reduce the level of harmonics in the electrical system. Harmonics are typically generated by nonlinear loads such as variable frequency drives, or VFDs, and electronic ballasts. 26thly, consider power factor correction. Power factor is a measure of how efficiently electrical power is used. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction capacitors can be used to improve the power factor of the electrical system. 27thly, regarding energy efficiency, implementing energy-efficient practices can help reduce energy costs and improve the sustainability of the electrical system. Energy-efficient practices include using energy-efficient lighting, installing variable frequency drives on motors, and optimizing the operation of HVAC systems. 28thly, think about arc flash hazard analysis. An arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. An arc flash hazard analysis can help identify the potential arc flash hazards in the electrical system and determine the appropriate safety measures to protect personnel. 29thly, regarding personal protective equipment, or PPE, using personal protective equipment such as gloves, safety glasses, and arc-rated clothing is important for protecting personnel from electrical hazards. The type of PPE required will depend on the specific hazards present. 30thly, consider lockout/tagout procedures. Lockout/tagout procedures are used to ensure that equipment is energized before maintenance or repair work is performed. Lockout/tagout procedures should be followed whenever working on or near electrical equipment. 31stly, when dealing with confined spaces, working in confined spaces can be dangerous due to the risk of exposure to hazardous atmospheres. Confined space entry procedures should be followed whenever working in a confined space. Confined space entry procedures include testing the atmosphere, providing ventilation, and using a spotter. 32ndly, regarding electrical safety audits, conducting regular electrical safety audits can help identify potential safety hazards and ensure that the electrical system is in compliance with safety regulations. Electrical safety audit should be performed by a qualified electrical safety professional. 33rdly, regarding emergency procedures, having well-defined emergency procedures in place is essential for responding to electrical emergencies. Emergency procedures should include instructions for shutting down equipment, evacuating the area, and contacting emergency personnel. 34thly, think about electrical system maintenance. Regular maintenance of the electrical system is essential for ensuring its safe and reliable operation. Maintenance should include inspecting and testing equipment, tightening connections, and replacing worn or damaged components. 35thly, regarding record keeping, maintaining accurate records of electrical system maintenance, inspections, and repairs is important for tracking the performance of the system and identifying potential problems. Records should be stored in a safe and accessible location. Remember to always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns.